Hey everyone, today I'll be doing Leetcode 567 permutation in a string. So not to be confused, I'll make the description a bit simpler. They give you two strings and you have to return true if at any point a permutation of S1 exists in S2. So really that may sound confusing, so I'll make it simple. They give you S1, right? And we have to check if a permutation of this exists in this. So intuitively, we take this string and we walk through it. And we have to walk through all the windows that are the same length as S1, right? Because you can't have a permutation of different lengths because you have to include all the characters. So this is length 2, so we'll do all length 2 windows. And we have EI, is this a permutation? Nope. ID, nope. DB, nope. BA, yes, this is a permutation of AB because you see there's one A here and one B here. So we return true at this point, and that's the problem. Doing another example really quickly, which is example 2 in the problem. We have this, we take this, like such. We take this one, and we look through here, EI, nope, ID, nope, DB, nope, BO, nope, OA, nope, AO, nope, OO, nope. So this is false. So this is true. This is false. It has to be a contiguous permutation. So that means that we can't take this B here and we can't take this A here and make it like that. They have to be connected. So windows, right? So you might be thinking, even though it says permutation, it might sound complicated. It's really just the is anagram problem, a modified version of it, of course. But basically, you just want to find an anagram of S1 in S2. I guess that's a better way to put it. So to do that, let's start with this, what we just did there manually. Let's have some mechanism where we can walk through all the windows of S2. But first, we have a very easy edge case. And that is, if the length of S1 ever exceeds the length of S2, we can return false immediately. Because if this is ever the case, there's no way we can find a permutation of this in this. We won't even have enough characters, right? So that's an easy one to do. The next thing we can do is start to prepare to walk through S2, the length of S1. So we can do that. And we will just go through the length of S2 at the beginning. And then another thing we will do, because as I said, we kind of want to frame this as the is anagram problem, right? We're going to need a balance. Now a balance is just the counts of characters, right? So we can name it counts, balance. I like to name it balance because it's a little bit better. So let's go final int balance. And what this actually is it represents all 26 lowercase characters. And we are allowed to do this because look at this constraint, only lowercase English characters. So 0 to 26 for every English character. And then the very first thing we want to do is we just want to knock out S1. Because we're only counting S2 at this point. We're going to go through all the windows, count all the windows frequencies. So we want to fill this balance with S1 and like pre-populate it. So we'll go and we'll do that. We will go for basically for final character C in S1.toChar array. We will just go balance C minus A. And we will go minus minus. You can do plus plus, minus minus. We're decrementing this. So the idea here is now we've counted all the S1s. So there must be a window in S2 that balances this out, makes them all 0, right? And just to keep this clean, let's write a little helper method that will check if a balance is ever balanced. Very kind of silly thing, but we'll go final int like this, balance. And then we're just gonna return, we're just going to make sure that these are all 0, right? So we'll go for int b in balance, and if b is ever not equal to 0, we know that we can return false. Otherwise, we made it through the whole thing and we can return true. So then now that we have this abstracted away, we can start to organize this in a better fashion. And this is actually a Boolean here, like such. And this helper method itself is actually O of 26, constant time, because we're just checking all 26 characters, right? So that helps us kind of organize things. So we have this counted. So the next thing we have to do is count all the windows. So how do we do this? So if I is ever lower than S1, we haven't even reached the window yet, so we should just count it. So if I is less than S1.length, we should just simply count it and do nothing else, right? So we can do that by, and just to organize this, let's get the current character as well, which is going to be s.carat I. Okay, so that way we can go like this, and we just count it. Because at this point, we don't have the window yet. We just have to count it. But at this point, we have reached the window, which means not only do we have to count it like this, which we can do at any point, so we can move this outside of here, and then actually we can make this like this. So if we have reached it, not only do we want to count it, we want to decrement the one that the window fell out of, right? So that starts to get confusing, so I'll explain that. I'll stop here and explain it. We have this. So say we are at E, we count it in the map. We're at I, okay, we count it in the map. We check if it's balanced, all that stuff. Then at I, if it's E and I, we want to check if it's actually a valid permutation. But then the moment we get to D, we don't want to count EID. We have to remove I because we just want to have this ID. So we should remove E as well. So we can do that here. And we can do that by, I'm sure there's a better way to do this, but if I is equal to S1.length, or actually what we can do is we can go, if it's greater than S1.length, we should start to remove the one that fell out of the window, right? So we'll go C minus A, and actually we shouldn't even go C. We can go final.character, C to remove. This is like the one that fell out of the window. I'm not very good at naming, but we'll do S1.carat, and this we can go I minus, let me think, S1.length, I think will work. Let's use this here. So if we're at 0, 1, 2, 2 minus 2 equals 0. Okay, yeah, that'll work, yeah. So we'll go like this. So we have our C to remove. So C to remove minus A minus minus. So we kind of remove this from the count, right? And we'll bring this down just to make it a little more clear here. So this is removing that one that fell out of the window. Now at this point, no matter what, we can check if it's balanced. So if is balanced, balance, we can just return true immediately. So after this, we can return false because that'll mean we never found one. And let's run this. And looks like we're gonna have to do some live debugging here. So we have false, and let's figure out why. This case 2 here is false. Okay, I figured it out. So basically, it's something really stupid. I had this here, and you just needed this. The reason why I paused it is I wasn't not really sure how long that would take. So okay, so we have it here. We ran it. Let's run it again. And the reason why you have to do equals is because actually, see if we get to D, which is 3, it fell out of the window, but this length here is actually greater than or equal to it. So we have D, and then we have to, you know what I'm saying. So basically, so D here, it's because I would actually be 2. So kind of like it's just a 0 index problem. So let's submit this, and then we can talk about time and space. Looks like it's fairly decent. So then what we can actually do here is talk about time and space. So let's minimize this now. And then let's talk about the time here. So we have to, immediately we know that we're walking through S2, right? This operation here is going to be O of S1, but S2 is always going to be longer. So let's just think O of N here, worst case or whatever you want to call it. This loop here is also O of N. But they're separate loops, so you know we're just at 2n now. This here is really nothing. We're just counting something, so it's constant. Let's go here and let's not print this out. And this is balanced. We already figured out what this is. It's O of 26, which is just equal to constant time here. So overall, I don't see really anything concerning. We have O of n, 2n, which is O of n. So we've got time is O of n, and space is constant space, because really all we're doing is counting the characters. We're just holding this, and this is fixed 26 size, and that's due to the